first unit, Introduction to Software Engineering. What are the things we are going to cover? It's a very basic chapter. First thing we will discuss what is software development. Before going to start that, we will understand what is software, what is hardware. We will try to compare software versus hardware. Then to develop the software, we are going to follow a phase development life cycle, that is SDLC. We will understand the SDLC. Then we will talk about the phase development process. Then we'll move towards the next part called as what software process. After the software process, we will focus on characteristics of software process, means what should be the special treatment given to the software to develop it. So each and everything we will try to cover up. Then to develop the software, as we said, SDLC is required, and inside this SDLC different phases are there. And based on their level of implementation, based on the style, we will have a different models. Models are nothing but abstract representations of the systems, so that we will represent into different forms, and very common of them are waterfall model, prototype model, iterative model, spiral model, and most commonly used V model, which is known as verification and validation model. And at the last we will discuss about the agile project management, introduction to agile project management. So this entire syllabus I am going to take part into 4 different parts. So for this subject there will be 4 parts. So first part we will focus on SDLC, software process and characteristics of software process. Third part we will focus on process development models. Third part we will focus on agile project management, and fourth and the last, which will be a conclusion of all the parts. So let's start with the first thing. That is, what do you mean by the term called as what? Software. Or before going for the software, let's understand what is hardware. Hardware that we can touch, we can see through our eyes, we will call it as what? Hardware. Example, USB pen drive, CD, computer. These are examples of hardwares. Now what is software? We cannot see through our bare eyes, which are intangible. We are calling it as what? Softwares. So what makes a difference between software and hardware is, if we take comparison, so hardwares can be touched, softwares cannot be. This is the point. Now comparative, moving again back to the basic idea, how you will make a differentiate between softwares and hardwares is what? Hardwares, if we see, they are the simplest part, but whereas compared to the softwares are need some special treatment or some attentions or some different approaches. So the difference we need to understand, difference between software and hardware we have to find out. So we'll come back to this slide after taking few further slides. So let's focus on the next part, that is, what is software. So different definitions are there. So IEEE, most standard parts, defines the software as collection of computer programs, procedures, rules and associated documentation and data. So if I say simply, what is software? Software is equal to computer programs plus procedures plus rules and associated set of document. So programs are nothing but instructions. Procedure, these are telling how to run away these all the parts. We simply call these are nothing but rules and regulations. Procedures are nothing but prototypes. And associated document, these are the some extra things which we need to take into considerations regarding how the software should be get installed, how the software should be get uninstalled, and if any trouble should comes, how we are going to handle this. All the things will be discussed in one separate set of document. When all collection parts, we will call it as what? Simple software. So simply remember the things what we do, we call it as what? Simply a program. and inside a program we write the instructions. Along with that, if we are going to provide some user manuals, that is documentation, that user manual plus programs will combine, simply called as a software. So I hope you are getting the definition of software. So simply remember, by comparison with program and softwares, we will try to give you more and more basic idea. So we will come back to the term called as what? Program. Difference between software and program. So simply remember, program is nothing but set of instructions, where software is collection of programs plus associated documents. Getting? So let's continue again. What do you mean by the term called as a software? So a program is generally complete in itself and used by author of that program only, but whereas the software can be used by various users. So understand the difference between software and program. Now this the simplest part is what we can say. Software we are saying so many, but what are the different types of softwares are there, or rather what are the different classifications of softwares? So what we can say, software can be applied in countless fields such as business, education, social sector, medical sectors, any sector. Tell me your sector and I will tell whether there is a software or not. So this is not the thing that there is a not a software. Today's world, there is not a single place where software is not there. So software is everywhere. So what are the different types of this software? So precisely we can say that software comes as a different types, like system softwares. The class of software manages and controls the internal operations of the computer system. We call system softwares. Example is Windows, Linux. The operating system related things are known as system software. Second is real-time software. The class of the softwares which observes, analyzes and controls real-world events as they occur. We will call them as a real-time softwares. So nowadays, if I take an example of oven, which is controlled by a software, so you have to set a temperature that 60 degree or 15 degree or 35 degree temperature. You set over there, you just give it an input, and the software built inside that oven, if the temperature achieves, automatically it cuts the power of real-time softwares. Engineering and scientific software. The class of a software which has emerged a power tool in search and development of next generation technologies. We are calling engineering and scientific softwares. Very of the examples are artificial intelligence, web-based software, personal computers. These are nothing but different types, or which may be a combination of these many. We will call as a classification of the software. So what the things we have covered so far? What is software? IEEE definition of the software, comparison software with hardware, and then we have discussed the different types of the softwares. Now we are moving towards the next part called as what? Software engineering. A branch of engineering where how to develop the software we are going to discuss. So that branch is called as what? Software engineering. So software engineering is the discipline that attempts to provide methods to handle this complexity and enable us to reduce reliability of software systems with maximum productivity. We will call it as what? Software engineering. And further definitions we can have, like it's an application of systematic, disciplined, quantifiable approach to the development, operation and maintenance of the software. Standardized approach to program development both in managerial as well as technical aspects, and its main objective is to help developers with for obtaining high quality software. So what is software engineering? It is not only focusing on the technical part, it is focusing on managerial parts also. This is not only the things that we will use only for the development, but after a development, further operation and its maintenance. These all the things will be detailed discussed in the terminology called as what? Software engineering. So it's a specialty where we can have a different approaches compared to Means we will implement all engineering principles for development of the software, not only with the technical as well as manager or management perspective also. So this entire software engineering approach has the two parts. One is phased development process and second is manage the process. Now this phase development process we can say SDLC, and management part we will discuss as a managing the software process. So this entire software engineering is implemented in one specific approach known as software engineering approach, and whose basic objective is to get consistency, lower cost, high quality and small cycle time, means with less time span, high quality at lower cost with consistent and scalable. These are the basic objectives behind the software development or software engineering process. Now moving further, we need to understand some terminologies like what is project, what is process. So let's focus on that part first and then we'll come back to software engineering approach. So let's focus on the first thing. What is software project? Project, to build a software system within cost, schedule and with a high quality which satisfy the customer. So project means what you are going to do, that we will discuss as a software project. Second, process. The process, how you are going to achieve it, we will call it as one process. So it simply talks about what we can say, what to do, how to do, when to do to reach at a certain goal. We will call it as one process. And third is simply what we can say, process models. So the way we are going to implement means let's take simple example. We'll take example of academics. So we are sending almost 10 months to get one complete academic years. Up to 10th or might be up to 12th you go with an year wise patterns, and in engineering you have started with semester pattern, means the whole 10 months considered as one academic year, or will be divided it into two parts. Thus the time duration is the same but the way we are going to implement is different. That nothing called as a patterns, and that patterns are nothing but the models. The way we are going to implement or the way we are going to represent it may be going to get changed based on time to time scenarios. We are calling it as what, development process. So in case of software development we have so many different development processes that we will discuss in upcoming parts. So let's start with the first bit called as what, phase development process. So we are talking about software engineering and how we are going to develop the software, that will be discussed inside software engineering. And software engineering implement the phased development process, and that phase development process consists of the 5 steps, or what we can say 5 phases. What are that 5 phases? First is, simply remember, analysis. Second is designing. Third is coding. Fourth is testing, and fifth is deployment. So this software engineering process implements phased development process which covers 5 different phases. So it is known as a 5-phase development process, and by implementing these 5 different phases we are going to implement or we are going to develop the software. So it is known as software development life cycle, SDLC. SDLC stands for software development life cycle, and it has how many phases? Only 5 phases. What are that 5 phases? Analysis, designing, coding, testing and deployment. So simply remember it is as SDLC and it covers 5 phases, A, D, C, T, D. Is it clear? Okay, we'll take a pause here. In next part we will see what is ADCT with each and every phase.